Right now, at this exact moment, you are being pulled toward the center of the Earth. Through your chair, your floor, the ground beneath you, a force is holding you here. It reaches through solid matter, crosses empty space. It works across billions of kilometers without touching anything. And nobody, not even the greatest scientists in history, fully understands why it exists. You have felt gravity every second of your life. You have never questioned it. Today, that changes, because gravity is not just a force. It is the deepest mystery in all of physics, and the answer to why it exists will change how you see everything. Welcome to Why. Before we ask why gravity exists, let us understand what it actually does. Because most people think they know, and most people are wrong. Gravity is not just what makes things fall. Gravity is what holds the moon in orbit around Earth, what holds Earth in orbit around the sun, what holds our entire solar system together, what holds galaxies, containing hundreds of billions of stars, from flying apart. Gravity is the architect of the universe. Without gravity, matter would never have clumped together after the Big Bang. No stars would have formed, no planets, no solar systems, no you. Every atom in your body was forged inside a star that only existed because gravity pulled hydrogen together until nuclear fusion ignited. You are here because gravity existed first. The first person to mathematically describe gravity was Isaac Newton in 1687, and his answer was brilliant, and also completely wrong about why. Newton watched objects fall. He saw the moon orbit Earth. He realized these were the same phenomenon. He wrote the equation. Every object with mass attracts every other object with mass. The more mass, the stronger the pull. The greater the distance, the weaker the pull. This equation, the universal law of gravitation, predicted the orbits of planets with extraordinary precision. It allowed us to calculate exactly where planets would be centuries in advance. It is still used today to calculate spacecraft trajectories. But Newton himself admitted something extraordinary. He had no idea why gravity worked. He wrote, "I frame no hypotheses. I do not know the cause of gravity. I only describe what it does." For 200 years, that was the honest answer. Gravity works. Nobody knows why. Then in 1915, Albert Einstein did something that changed everything. He said gravity is not a force at all. It is something far stranger. Einstein's general theory of relativity proposed something almost impossible to believe. Mass, any mass, bends the fabric of space and time around it. Not metaphorically, literally. Space itself, the actual fabric of reality, curves in the presence of mass. And what we call gravity, what we feel pulling us down, is not a force being applied to us. It is us following the curve of spacetime. We are moving in the straightest possible line through curved space. Think of a heavy ball placed on a stretched rubber sheet. The ball sinks and creates a curve. If you roll a marble near it, the marble curves toward the ball. Not because a force is pulling it, but because the sheet is curved. Earth does the same thing to spacetime. The moon follows that curve. We follow that curve every time we fall. Einstein's theory predicted things Newton never could. Gravitational waves, black holes, the bending of light around massive objects. All confirmed, all real. But even Einstein, with his extraordinary insight, could not answer why mass bends spacetime. Physics has two great theories: general relativity, which describes gravity, and quantum mechanics, which describes everything else. And they completely contradict each other. Quantum mechanics describes the universe at the smallest scales: particles, atoms, subatomic forces. It works through particles. The electromagnetic force is carried by photons, the strong nuclear force by gluons, the weak force by W and Z bosons. Physicists predicted gravity must also have a carrier particle, the graviton. But nobody has ever detected a graviton. Not once, not even close. And when physicists try to combine general relativity with quantum mechanics, the mathematics breaks down. The equations produce infinities, numbers that make no physical sense. The two greatest theories in all of science are incompatible with each other. This is one of the biggest unsolved problems in physics. Gravity, the force you feel right now, is so weak and so strange that it refuses to fit into our best understanding of the universe. We can describe it, we can predict it, we can use it to land spacecraft on Mars, but we cannot explain what it fundamentally is. Here is something that will make you see gravity completely differently. Gravity is extraordinarily weak, embarrassingly weak compared to every other force in the universe. Consider this: a small magnet can pick up a paperclip, defeating the gravitational pull of the entire planet Earth. The electromagnetic force which holds that magnet together is 10 to the power of 36 times stronger than gravity. That is a 1 followed by 36 zeros, more than a trillion times stronger. The strong nuclear force which holds atomic nuclei together is even stronger. Gravity is the weakest force in the universe by an almost incomprehensible margin. And yet, gravity is the only force that operates at cosmic scales. The other forces cancel out over large distances. Gravity never cancels. It always adds up. This is the great paradox of gravity. So weak that a child can defeat it by jumping. So persistent that it shapes the entire universe. Why is gravity so weak? Nobody knows. Some physicists theorize that gravity may be leaking into other dimensions, spreading across extra dimensions of space that we cannot perceive. This would explain why it seems so weak in our observable universe. But this remains a hypothesis. If you want to understand what gravity truly is, look at its most extreme expression: the black hole. A black hole forms when a massive star collapses under its own gravity at the end of its life. The mass is compressed into an infinitely small point, a singularity. At the singularity, our mathematics completely fails. Equations produce infinities. The laws of physics as we know them stop working. Around the singularity is the event horizon, the point of no return. Gravity here is so strong that nothing, not even light, can escape. Light, which travels at 300,000 kilometers per second, the fastest thing in the universe, cannot break free. Time itself slows near a black hole. If you could hover just outside the event horizon, time for you would pass far slower than for someone far away. You would age more slowly, not as a metaphor, as a physical reality. Gravity bends time. Einstein predicted this. We have confirmed it. GPS satellites, which orbit Earth at high altitude where gravity is slightly weaker, run slightly fast. Engineers must correct for this gravitational time dilation every single day. You use GPS, which means every time you navigate, you are correcting for Einstein's theory of gravity. In 2015, humanity felt gravity for the first time. Not just experienced it, but detected its ripples traveling through space itself. Einstein predicted in 1916 that when massive objects accelerate, they create ripples in the fabric of spacetime. Gravitational waves, traveling at the speed of light, stretching and compressing space itself as they pass. For a century, nobody could detect them. They were too small. A gravitational wave passing through Earth might stretch and compress it by less than the width of a single proton. Then LIGO, the Laser Interferometer Gravitational Wave Observatory, detected them. Two black holes, each around 30 times the mass of our Sun, had spiraled together and merged 1.3 billion years ago. The collision released more energy than all the stars in the observable universe combined, in a fraction of a second. That collision sent gravitational waves across 1.3 billion light-years of space. This was not just a scientific achievement. So, why does gravity exist? Here is the honest answer. We know gravity is the curvature of spacetime caused by mass. We know it governs the motion of everything from apples to galaxies. We know it slows time, bends light, creates black holes, and sends ripples across the universe. The greatest minds in physics, from Newton to Einstein to Hawking, have described gravity with breathtaking precision. None have explained its origin. And this is not a failure of science. It is science being honest about what it does not yet know. Gravity holds you to this planet. It holds this planet around its star. It holds our galaxy together. It shapes the structure of the entire universe. And it does all of this silently, invisibly, through a mechanism that remains one of the deepest mysteries in all of human knowledge. Next week on Why, we ask why Earth spins and why it never stops. A planet rotating at over 1,600 kilometers per hour, perfectly balanced, for 4.5 billion years. Why did it start? Why hasn't it stopped? The answer connects to the very birth of our solar system. If this video made you feel gravity differently, subscribe to Why. Share it with someone who deserves to see the universe differently too, because why is always worth asking.